Right. So, project 1.12 on page 31 of the Quolco book is actually a good project to look at to try and understand the general approach for this book. So it's worth going over in some detail. So the idea that the approach that the author is trying to take in this book is to look at mathematics as an experimental science, or at least a science with experimental aspects to it. So you want to be, trying things out and playing around, and so that as I'm explaining things, this will give you an idea of kind of the way that you can kind of play around with the ideas that are presented in the book and use them to try to solve programming problems. So let's look over the problem again. It says, write a function that expresses the idea of repeated multiplication with a generic decrement and length. In other words, write a function repmult that takes three inputs, n, d, and l. And so one thing to note here in the book, he's talking about decrement, which starts with a d, and length, which starts with an l, and he has variables d and l. So that's a clue to you that d is going to be the decrement, and l is going to refer to length somehow. Okay, so let's see what it says. And it says the output of repmult ndl should be n times n minus d times n minus 2d times n minus 3d times n minus the quantity l minus 1 times d. If this doesn't make sense to you on first blush, don't worry about it. We're going to, start playing around, and it should become clear as we stumble our way through here. So it says so that repmult 15, 2, 6 will output this right here. So it's going to output 15 times 15 minus 2. Okay, so there's a little bit, we can start seeing a little bit of parallels here. So 15 is our n, right? And 2 is our, so the inputs are n, d, and l. 2 is our d, our decrement. And 6 is our l, the length. Okay? So we have 15 times 15 minus 2, so that's our n minus d. 15 minus 2 times 2. 15 minus 3 times 2. 15 minus 4 times 2. 15 minus 5 times 2. Okay? Now notice we get up to 15 minus 5 times 2, and our L input is 6. So the 5 might look a little funny here, but we can see a 6 if we count how many factors there are. There's 1, so 15 is the first factor. So there's 1, 2, 3, 4, 5, and 6. So there are 6 factors. Okay, so that's our 6. And a 2 does appear every time except this time. So we'll have to figure out why there's no 2 in this version, in this factor. But we have here we have a 2. Here we have a 2, a 2, a 2 each time, right? And we have a 15 each time. So that's our n. Okay? So these are just things to kind of notice, okay? And then and this equals 15 times 13 times 9 times 7 times 5, or 675,675. Okay? So now actually the very first thing, and this is just good programming practice, the very first thing you should do when you're writing a new program is devise a test. Okay, so let's see here. So what we want is we want to have a function repmult, and we said, so oh yeah, so test has two inputs, got and expected. So this is the result we got, and then we'll put a comma and say the result we expected. So we're saying basically what we're told in the text is that if we write repmult 5, 2, 6, the result that we get from this function should be, or what we're expecting should be 675,000. Okay, so we can't run this yet because we haven't written the function. So let's write the function. Def repmult, and the inputs are n, d, and l. So let's say n, d, l. Okay. And just to make sure our test is right, so because that's what we should expect, right? If this is the input, then that should be the output. So we know at least this one will work with these three inputs, yeah. So let's run that and make sure. So okay, so we got 675,675, and that's what we expected. But we're not quite done, right? Because this is only going to, we only know for sure this is going to work with these three inputs. So we need to start, stepping back a little bit to see how we can expand this out a little bit. So what I'm going to do, just so I can keep track of my steps, is I'm going to copy this function, and I'm going to just comment out the one in front of it. So that way, when I make changes, if I mess up, I can refer back to what I had before. Okay. So where did this number come from? Well, we know that it should come from that, right? I mean, that's what the book told us, but we like to verify. So let's make sure that that gives us the answer we expect. And yes, that's good. All right. So now we're ready for the next version. And the next version should involve this piece, right? So now we're kind of working our way backwards here, just making sure that that the author wasn't lying to us about some things first, right? And we need, to make this work in Python, we're going to need some multiplication symbols in between these factors, right? So let's do this. And that works. Okay. So far so good. So we're doing pretty much what the author told us to do, and it's coming out to the right number. The problem is we have to make it work for all these different values, right? Well, again, this is kind of a complicated piece, and what we want to do is start breaking this down a little bit and simplifying. So the first thing I'm going to do is just, again, copy, so I'm keeping track of what I did before. And then I'm going to say, you know what? I'm going to break this into two pieces. I'm going to have my regular repmult repeated multiplications. But then I'm going to say, well, this is the repeated multiplication that worked on 6 different factors. I'm going to have another one that works on just on the 5 factors that are left. So I'm going to say rep mult, I'll call it L5, because my L is going to be 5 at this stage. I'm not even going to bother at this point changing, trying to change ND or L or anything. I'm just going to, because I'm still really faking it. I'm going to say rep mult L5 here. So now I have, and it's the same 3 inputs. So at this point, I'm still not doing anything with the inputs. Well, I will worry about that when we have this developed a little further. But now I'm breaking things down so that I'm just going to multiply Oh, you know what I'm seeing? So one thing I'm noticing here is that when you do, when you write out mathematical descriptions of things, there's a tendency to go up, for the numbers to get higher and higher. So here we're going 2, 3, 4, 5. When you're doing recursive stuff, you kind of want to go backwards. So before I even start teasing this apart, I think I want to look a little bit more carefully at what's happening here. So it's a good thing I commented out. And now, a quick way, if you haven't found this yet, a quick way to comment things out is to use the control. On my Mac, it's Control 3. I think it's the same thing on PCs. But if I hold down the Control key and press 4, it uncomments things. Okay. So what I'm thinking now, and actually I'm noticing something else too. Another thing that you want to do for programming is, especially because we know we're going to be doing some recursive stuff, right? Because this comes after, this says to go look back at factorial and power, and those are recursive functions. So one thing we kind of want to do is to try and make all of these factors look kind of the same. So here we have 15 minus 2 times 2, 3 times 2, 4 times 2, 5 times 2. Well, we can make this into 1 times 2, right? So that should be the same thing. 15 minus 1 times 2 is the same as 15 times 2. And this one we could make into 15 minus 0 times 2. Right? So now we have, see, these all look a lot more similar. This is 0, 1, 2, 3, 4, 5. Okay? So that's a good trick to kind of help yourself see a little bit more clearly what's going on. So that's one thing. But then also, like I was saying, well, let's test this one and make sure that works. I want to test all along to make sure everything's, that as you're changing things, that you're not messing yourself up. So here I'm going to make a copy. And since recursive stuff generally, so my L is going to be a 6, my first input, right? So rather than trying to go 0, 1, 2, 3, 4, 5, I want to go the other way. I want to say 5, 4, 3, 2, 1, 0. Okay, so now I've got all these kind of looking the same, and I know I can go, and I'm going in the kind of direction you would expect to go doing some kind of a recursive function. So let's just check that one. Yep, we're still good. Okay. Okay. So now what? Okay, so now let's start doing what I was thinking about before. Now let's start breaking this down into other functions. So let's make this one. I'm going to use that stuff in a minute, but let's say we wanted to just take the first bit here, this 15 minus 5 times 2, and then just call another function that is going to deal with the 5 factors that are left. So I've got this one factor here, and I'm multiplying that times these other 1, 2, 3, 4, 5 factors, right? And I'll just say NDL. I'm not even going to worry about what N and D and L are going to be at this point, because I'm still just dealing with raw numbers. I don't have any variables in here, so I'm not going to worry about that yet. And I'm going to say def rep mult L5 NDL, and that's just going to return this. Okay, and let's check that and make sure it runs. Okay, so I'm kind of trying to work out some way of simplifying more and more and more each time. So you can kind of see where I'm going here, I think. Let me comment this out. So I could continue this process and make, I'm just doing copy and paste, but this one's going to deal with 4 of the factors. So I'm going to define this guy. Oh. I'm going to define this guy as those 4, right? So at each step, so how's this working? Well, this function is calling this function, right? So now this guy is going to be multiplied by the result of this function. And right, and this function is 15 minus 4 times 2 multiplied by that. If this seems a little confusing or a little hairy, one thing you can do is go to this online Python tutor and just punch it in, and well, we have to run it, don't we? So I have to say rep mult 15 comma 2 comma 6, right? And then do the visualize execution and just kind of step through. So now we're defining, the first thing we do is define the function. So we create this global variable that points to this function. We create a global variable. Basically, it's just the function name is a global variable that points to that function. Okay, and then we have this. So we have these 3 functions: rep mult L5, and rep mult L4. Okay, and now we're going to call rep mult 15 comma 2 comma 6. And what happens? So we start out with our variables, our parameters are 15, 2, and 6 right here, and these aren't going to change because we didn't do anything with them. So I guess really the important thing to notice is that when we start out by saying 15 minus 5 times 2, which is what? 15 minus 10, that's 5 times whatever this is. Okay, And then the next step is to go there and say, okay, now we're going to multiply 15 minus 8. That's 7, right? 7 times whatever this is. Okay, and then we're going to step down here, and this is actually going to return something. So let's see if we go here. What does that return? So that returns this number here, 19305. So 19305 is basically this times that times that times that equals 19,305. And then as the next step, now we've popped back up here, and so now we're going to multiply 15 minus 4. We're going to multiply 7 times that number that we had before. I don't remember what it was, and we got this. We got 135,135. And then we're going to multiply that number times, when we pop up here, whatever this one is. And that gives us the 675,675. Okay, and I mean, you can play with this. This is really nice because you can go, you can run this back to the beginning. You can go back and forth and say, oh, I can't remember what that number was, and just kind of go trace through as many times as you need to make sure you're clear on how that works. But anyway, once you're clear on that, then you can kind of see, oh yeah, okay, so now I can kind of keep going with this. So I can say, I can do the next one here, and again, like I said, this is the experimentation part, right? So you need to kind of roll up your sleeves and get in and try out the functions, run them in the Python tutor, run them in idle, and get a feel for what's going on. I'm going to return this, and I'm going to do it again. And so see, each time I'm renaming this 5432, so I go down to the next one. So the next one's going to be 2, because I'll just have 2 factors left. And let's see, yes, let's make that one. I'm going to return that. And then I'll just have 1 factor left. That's that one. Oh, it's going to be a 1 now. So this is going to be a 1, and I'm going to return this. Now, actually, what I want to do is I'm going to even stick another one on here. RepMult. It's helpful to always have a 0 case, just because, what if somebody puts in a 0 for one of these values, and you'll see more clearly what I'm talking about in a little bit. But it's good to have a 0 case, just as a general rule. And so for my 0 case, what I'm going to do is I'm just going to, because I'm multiplying, this is my last one, right? 15 minus 0 times 2. So what else is there left to multiply? Well, we can multiply by 1, right? So if I just return 1 in this case. So now we've got all our cases. And now you can start to see a pattern here, right? Because for our n, if our n started out as 15, right? So in our test, we're doing 15, 2, 6. So our n started out as 15. Our n stays 15 all the way through here, right? So wait, first let me run my test. Oh, there we go. We're good. Okay. So n stays 15 all the way through. D is 2. And we see we have a 2 all the way through. So let's try and let's take care of those first. So n, we can replace all the 15s with n's, right? That should work. N, 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 N. All right, let's try that one. Because n is always 15, and if I'm feeding in a 15, that should work, right? Yeah, that looks good. All right, so now, oh yeah, and D is 2, so we have all these 2's here, nicely lined up. And you see that's why we did the 1 times 2 and the 0 times 2 at the beginning. It's good to have a nice pattern like that so you can follow all the way through. So we can make these all be D's. Okay, so let's try that. One module. Okay, we're still happy. Everything's good. So now let's see. Now we got to deal with L, right? So when L comes in, so we do have this number 5, 4, 3, 2, 1, 0 working its way down there, right? But L starts out as 6, doesn't it? Starts out at 6. So it looks like what we want, see, N and D, every time we make a call, N and D stay the same. But L changes each time, right? L gets smaller each time. So one thing we want to do is make sure we make L get smaller each time. Okay, but there's one other thing we got to worry about, which is that this isn't L. This is 1 less than L, isn't it? If L is 6, that's 1 less than L. So what we need to do here is, instead of making this L, we need to make this be L minus 1. Okay? And in fact, we did see this, N minus L minus 1 times D, right here, didn't we? N times L minus 1 times D. So that's actually what's happening algebraically too. If you think about it, we have except they're going in the other direction, right? They're going from smaller L's to bigger L's. But if we start out with L being 0, N minus, then we can think of this as being N minus 0, minus 0D, right? And this being N minus 1D, N minus 2D, N minus 3D, all the way up to N minus L minus 1. So if we count 0, 1, 2, 3, up to L minus 1, then we're going to have L factors all together, right? Okay, so I'm going to pop this back. And pop this back the way it was. Okay, but so that's what's going on here, is that we have this L minus 1 going on here. Now, this time through, we started out, this was 6. We're subtracting 1, so we're going to pass a 5. So this 4 needs to be L minus 1. I mean, we need an L minus 1 here because 5 minus 1 is 4. This time, so we got a 5. So we started out, L was 6, then we passed down a 5. So we had to change that, right? Now we're going to pass down a 4. So you need L minus, we need to replace the 3 with L minus 1. Now we're going to pass a 3. So we need to replace the 2 with L minus 1. because then 3 minus 1 is 2, right? Here we're passing, so now at this point, L minus 1 is 3, so we're passing a 2. So this 1 needs to be replaced with L minus 1, because 2 minus 1 is 1, right? And now, here we see, so here we're at 2, at L being 2, so L minus 1 is 1. We need to replace the 0 with L minus 1, okay? So now, all of these guys should work. Run module. Okay, looks good. And again, like I said, you can always, you know, kick this stuff over to the Python tutor and play around with it in there. Just copy that in. Make sure you have your, you know, your rep mult down at the bottom, so you're actually running it, and you know, test that, run it through, make sure everything makes sense, and then what else? So now we see, look at this. So all of these functions are looking very similar now, aren't they? The only thing actually that's different is that we're calling rep mult 1, 4, 1, 3, but the actual functions themselves, rep mult 1 L5 looks just like this one, right? So that's good. That means we're going in the right direction. The thing is that we still have this one is different down here, right? So I guess probably for this problem, maybe the best way to think about it is, what if we wanted to test this one? How would we make that happen? Well, so the first thing you had to do is figure out what this number is going to be, right? So we know that for that rep mult 1526 gave us, and notice, okay, so notice all these numbers are separated by 2, right? 15 minus 2 is 13, 13 minus 2 is 11. So the decrement is 2. So that the decrement is the difference between these consecutive numbers. And then the 6 tells us how many factors, right? So 1, 2, 3, 4, 5, 6, okay? So if we have, so if we started with 15 and we only had 5 factors, then we would be multiplying 5 times 13 times 11 times 9 times 7. So let's see what that equals. Okay, so that equals 135,135. So let's copy that over to here. Could also do this multiplication in the shell, couldn't I? Okay, so so let's see if that works. So let's run that. Ah, something's wrong. Look, we got this huge number, and we expected that. So what happened here? Well, what happened was we started with 15, 2, 5, but we actually let's run it through the tutor. I think that's a good way to show it. So, oh, we already have it copied. So let's see what happens when we try to go 5. Okay, so visualize execution. Let's see. Looks like the forward key is a little bit out of range of our picture, but I'm gonna click it anyway, and you'll see what's going on. So we're gonna go through and define all our functions. So we have a bunch of global variables this time. And then we're going to run repmult 15, 2, 5. So let's see what's going on here. So we go 15, D is 2, L is 5. Then we're going to go down to, L is 4, L is 3, right? Because now we're in that one. L is 2. Here, L is 1. We're down to L is 1. Now L is 0, but even though L is 0, we're still doing this multiplication here. So on our 0th one, we really should be just multiplying times 1, right? But then we still did that multiplication, and now look at L is minus 1. But so we went past the end, basically, right? We kept doing, getting more multiplications. So now, what is this one going to come out to be? Well, that returns a 1, but now we're multiplying 1 by, let's see, we're multiplying 1 by, how did that happen? 15, because it's 15 minus negative 1. If L is negative 1, so we get negative 1 minus 1 is negative 2, and then N minus a negative 2 is 17. So we got ourselves in trouble because we went too far. Okay, so what we need is a way to stop the action once L gets down to being 0. We don't want to be, doing operations with L being a negative number. So if L's 0, then we've gone too far. So what we could do is down here we could just say if L is 0. And let's just return 1, because that's really what we initially had set up to do, right? Our initial idea was once we get down to 0, we're just going to return a 1, right? So here on the fifth try, when we get down to here, we should just be returning a 1. We don't want to be doing operations on L less than 0. Okay, so let's and again, like I said, if that's not clear, play around some more with idle, play around some more with the Python tutor, and make sure it makes sense. But now let me run this. Okay, so that's good. We expected 135, 135, and we got 135, 135. All right, so now we have the same issue, though. What if we want to do 4? Okay, so let's see, what is that? I'll do it in the shell this time. What is, so we want 4 factors starting with 15, and we have a decrement of 2 each time. So 15 times 13 times 11 times 9. That's 4 factors, right? And there's a difference of 2 between each consecutive factor. So there we go. That's what we want. 19305 is what we want that to be. So let's check. And that's if we just have 4 factors, right? So we can test that one. Oh, looks like we need another one of these checks for 0, right? So now when we get this far, okay, so remember with the original one we were starting with 6 and then going 4, 3, 2, 1, 0. If we just have 4, if we just have 4 factors, here's our first factor, here's our second factor, third, our fourth. So now when we go down here, we're at L equals 0. So we need to have that multiplication thing there. So let's do a run module. Okay, now we're good. All right. So it looks like, to be safe, we need to do this all the way up to the top, right? If that, and let's even put it in the first one for kicks, because now we could even have 0 as the input, as the input to the original function. So let's just do, go ahead and glomp all of these. So we want to do 3, 2, 1, and even 0. Okay, so if we put in a 0, we should get back a 1, right? That's what we're saying, is that. And let's see if that makes sense in the original definition here. So if there are 0 factors, basically, we're going to output a 1. No, depending on how you think about it, that could be, if you think about it in terms of powers, like if you say n to the raised to the 0th power, that's 1, right? So it kind of makes sense. Okay, so let's do that, and then if we're doing test rep mult once, then we would just have n would be the only factor. So 15 would be the only factor, so that should be 15, right? And then if there are 2 factors, that's going to be 15 times 13, right? Oh. So 15 times 13, oops. 15 times 13 is 195. So with 2 factors, it should be 195. And then let's multiply 195 times the next factor, and that should give us, so 195 times 11, right? So 15 times 13 times 11 gives us 2145. Okay, so these should all work now. So let's see. Yay! Okay, good. So those all worked. So now the last thing we have left to do is to make this guy recursive. And it looks like we're pretty well on our way, right? Because we have now all these functions look pretty much the same. So I'm gonna copy this, except for the last one. But the last one does pretty much what all the other ones do once if L is 0, right? And that's really the condition that we need to worry about, is when L is 0. And that's what this was originally set up to handle, right, when L is 0. So let's see. Let's copy this. Actually, I'm just going to copy the first one because I'm going to do the recursion bit next. So I'll just copy this guy down to here, and I will comment out my previous stuff. So again, that's Command 3 to do that. And then what I'm going to do now is I'm just going to say, okay, so instead of just having to write out lots and lots of copies of this basically the same function, I'm going to say, hey, just call rep mult, right? And that will eventually get, L will eventually get down to 0 and return 1 at that point, and then these will keep popping out. Okay, so let's see, run module. Yeah. All right. So that's the solution. And now the other thing is you want to make sure on the algebraic side that you're clear what's happening algebraically. So what you would want to do to test your understanding at this point is to say, okay, what would the output of repmult 15, 3, 6 be? Okay, so you should recognize, so what are we going to do? Well, we're going to say 15 times 15 minus, now our decrement is 3, right? Times 15 minus 2 times 3 times 15 minus 3 times 3, right? So you should be able to create more tests for yourself and, work these out, and see what that comes out to. You could use the Python shell or calculator or whatever, and you should be able to make more tests for yourself to make sure that you understand what's going on here. So for these certain inputs, you should be able to use a calculator or the Python shell or something to figure out what these values should be. Okay, and once you can do that, then you understand the function for sure. So basically, so the idea here is going to be the decrement is 3, so the difference between each factor is going to be 3. So it's going to be 15 times 12 times 9 times 6 times 3. Oops. 1, 2, 3, 4, 5. Oh, do we want to go times 0? Let's make this a 5. Yeah, because 15 minus 15 is 0, right? If that's a factor, it won't be that. Well, we could leave that in. We can make it 6. And then that's going to be times 0. So the answer should be 0, right? And then you could do other ones. You could do one if this was a 5. What would it come out to, and so on. But so that's the basic idea of repmult, and hopefully that gives you an idea of how you work these problems, how you experiment on the mathematics, and you kind of move back and forth between the algebraic representations and the functional, programmatic representations.